Okay, so now we've got another one with common denominators, so that's cool. So we know we've got the y minus 3 on the bottom. And now this time we got addition in between, so it's not as tricky. So we've got a y squared, and there's none of these other three terms in there are a like term with the y squared. So the y squared doesn't combine with anything. Okay, and then we've got a minus 7y plus 5y. That is minus 2y. Then we've got plus a negative 3, which is just minus 3. Now, we would stop there, but if we can simplify further, we are expected to. So it turns out that the numerator does factor, at least I think it does. And we're going to get a that and a that. And these guys cancel, and we're just left with y plus 1, and that's it. That's the whole answer. So if you can cancel something, you are expected to do so. You won't be able to every time, but you got to do it. All right, now we finally are going to be doing some stuff with where the denominators are not the same. Okay, I think we can probably all agree right away that we just need to multiply by 4 over 4, and then we'll get the same denominators. Okay, let's start doing it that way. So then when we multiply these two fractions together, we get negative 12 over 8d. And then the second fraction didn't change on this problem. Sometimes it will, but not this time. Okay, then now we have common denominators. I can just say negative 12 plus 5 is minus 7, and that's it. Okay. Now, let's do this in a little bit more sophisticated way. Typically, what you do, at least when the problems are a little more involved, is you take your denominators, in this case 2d and 8d, and you factor them down. Well, the 2d is already factored. It's just 2 times d. But the 8d is going to be 2 cubed times d, because 8 is 2 times 2 times 2. And then you would build your least common denominator. You'd say, all right, well, we need a 2 and a d to satisfy the first denominator. The second denominator says, I need 3 2's. Well, we've already got 1, so let's just make it 3, and there, that'll satisfy both of them. He says, I also need a d. Well, we've already got a d there. So our least common denominator will be 8d, which is what we ended up with. And then we would say, all right, so what do we have to multiply the first denominator by to get 8d? Well, we got to multiply it by 4. So I do it to the top and the bottom. And then I say, what do I multiply my second denominator by to become the least common denominator? Well, they already match, so I don't need to do anything there. So in this case, we probably didn't have to get all technical on it. But as they get more challenging, we're going to want to use that method. Now we'll do something a little bit similar. And once again, you'll notice that the denominators are not the same. That's, well, get used to it. Okay, so let's start with factoring the denominators. The first one is 2 times 2 times x, and the second one is 3 times x. So the least common denominator, let's see, we're going to need a couple of 2's and an x. So a couple of 2's and an x. And then for the second denominator, we need a 3 and an x. Well, we've already got one, so I won't put another in. And so that gives us 12x. That's a variable, not a multiplication symbol. All righty. So I ask myself, what do I have to multiply the first denominator by to get the least common denominator? 3. So I'll do that to the top and bottom. Then I ask myself, what do I need to multiply the second denominator by to get the least common denominator? 4. So multiply that over itself. And so this gives me 3 times 4x plus 3. and this 4 times all of 2x plus 3. Okay, so I'll get 12x plus 9 over 12x minus 8x plus 12 over 12x. Okay, so we got common denominators, so we're home free. All right, so we'll do 12x minus 8x is 4x, and 9 minus 12 is minus 3. And I can't factor the numerator, so there's nothing I'm gonna be able to cancel, so I can't take this any further. As always, you're going to want to plug in the original problem before you've made any changes into y1 in the calculator, plug in your final answer into y2, go to the table, see if they match. Incidentally, there are 2 recordings of this section because I accidentally stopped recording at the end of the first one. Okay, so what do we got here? So once again, we've got, we don't have common denominators. So break them down. Well, the first denominator is just 5 and 3 v's. The second one, though, is a couple of 2's and a couple of v's. So we build our LCD. And we need a 5 and 3 v's and a couple of 2's and a couple of v's. Well, we've already got at least 2 v's here, so I won't put any more in. And that'll be 20v cubed. Alrighty then. So what do I multiply the first denominator by to get the LCD? Well, by 4. That's the factor out of all this that's missing. What do I multiply the second denominator by to get the LCD? Well, it already has the 4, and it has 2 of those 3 v's, so it needs 1 more and that 5. So 5v is missing. So we multiply, and we get negative 24 on top. And on the other one, we get 35v. I think, yeah. So now that we have common denominators, let's use them. Otherwise, what was the point in getting them? We get negative 24 plus 35v. And the numerator doesn't factor again, so I can't cancel anything. All right, so now we are getting common denominators, but the denominators have more than one term. Okay, so can we factor x plus 2 down? I'm going to use the same strategy. Factor the denominators. That doesn't factor. That doesn't factor. So there's a single factor here called x plus 2 and a single factor here called x minus 4. So the LCD is going to be x plus 2, that factor, times the other factor, x minus 4. Okay, so what do I multiply the first denominator by to get the entire LCD? X minus 4. Whoops, sorry about that. Okay, what do I multiply the second denominator by to get the LCD? X plus 2. Now you might be thinking, well, that's easy. All I got to do is multiply whatever this is, multiply it here. Whatever this is, multiply it here. That will work sometimes, and sometimes it will not. So that's why I'm using this process that seems long-winded, okay, to help you avoid problems. All right, so we're going to do x minus 4 times 2x. So that'll be 2x something squared minus 8x. And in the denominator, x minus 4 times x plus 2. And then we'll do 4x times the x plus 2. So 4x squared plus 8x, I think, yeah. And then in the denominator, the LCD. And of course, we notice that the denominators are the same. Yeah, that was what we needed to do. So in the numerators, we've got 2x squared minus 4x squared is minus 2x squared. We've got minus 8x minus 8x, which is minus 16x. Okay, now this time the numerator does factor, but when we factor it, we're still not going to be able to cancel anything because the numerator becomes negative 2x times x plus 8. And none of these three factors matches up with either of these. So you can just leave it like this, but you do need to know that for sure, one way or the other. And as always, plug in the original problem for y1, your final answer for y2, see if they match up. And if they don't, go find the problem. All right, I see that I'm either adding or subtracting fractions, so I do what I always do. I factor the denominators. Well, the first denominator doesn't factor, it's just linear, no GCF. The second denominator, I can pull a 3 out. And then once I have that, I use them to build an LCD. This gets very repetitive. So I need a factor of x minus 5. I need a factor of 3. And x minus 5 is already represented there, so I'll just leave it as is. Okay, so I say, what do I multiply this first denominator by to get the LCD? Just the 3. So I'll do 3 over 3. What do I multiply the second denominator by to get the LCD? It already matches up, so I won't multiply it by anything. And then I get 3x plus 3 over 3 times x minus 5 minus 2x plus 8. Second fraction doesn't change. Over 3 times x minus 5. I'll write it in factored form, that second denominator, just so the two denominators match up more obviously. All right, so let's use the power of the common denominator and say 3x minus 2x is x, and 3 minus 8 is minus 5. Oh, look at that. Hey, that's pretty cool. The x minus 5's cancel, and I'm left with just the 3 in the bottom. Now, everything from the top went away, so we just have a placeholder of a 1 there. And the answer is just 1/3, no variables. Weird. But notice, it was the same process as every other time. Factor the denominators, use them to build the LCD, multiply by what you need to, and et cetera, et cetera. Okay, so. All right, let's see what we got here. So, the denominators are different, and they're bigger and uglier. Who cares? Same process, factor the denominators. Let's start with that. Okay, in the interest of time, I am going to do them off camera. Okay, so the first denominator factors down to x plus 3 times 4x minus 9. Now, I've done these a bazillion times, so pretty much every time, they're going to have one common factor. Okay, the second one is going to be 4x minus 9 times x minus 4. Okay, so now we can build an LCD. Worthy of Mordor. Okay, so we need a factor of x plus 3. Cool. And we need a 4x minus 9. That takes care of the first denominator. Second one says I need a 4x minus 9. Already there. And I need an x minus 4. Got it. Okay, so what do I multiply the first denominator by to get the LCD? Well, it already has the x plus 3 and 4x minus 9. It is lacking the x minus 4. So I'll multiply by that. Second denominator is lacking the x plus 3. So I'll introduce that. Okay. So I'm going to get x minus 4 times 3 is 3x minus 12. Now the denominator, I'm going to write that out in the factored form. So we have, for the first fraction, we got the x minus 4. We also have the other two factors. I just like writing them in factored form because if I'm able to cancel something later on, well, it's nice to have it in factored form because that's the way to do it. All right, the second fraction, 1 times x plus 3 is just x plus 3, and we get that same denominator. And the order of the factors doesn't matter. Okay, so we got common denominators. Let's use them. And so we'll get 3x plus x is 4x. Negative 12 plus 3 is minus 9. And once again, a miracle happens. We have common factor on the top and bottom, so I can cancel them. And so then I'm left with a 1 on top. And on the bottom, x minus 4 times x plus 3. Don't bother multiplying it back out. You don't need to. It's just more work. That's how we do it. And it's the exact same process we've been doing throughout this entire video.